All right, cool. Hello, everyone. I'm Doug Hoyt, and we're going to talk about some regular expression stuff today. These are just, a bunch of different modules that you might find interesting. Some of them are, probably common you've heard of. Some of them maybe not so much. First one I want to talk about is regex debugger. It's a Damien Conway module. Really, really useful. It comes with this one utility called RxRx, and you can use it to do metering and find issues and see how your regex is actually matching at certain patterns in already existing programs, or also just in simple little test programs like this too. So I'm just going to show an example here. Basically, all I did was create a couple little scripts here, and into like this trivial as possible thing with nothing really, right? This is enough for RxRx to use them. RxRx, bang, what it does is it brings these two little parts. You have the matcher part, and then you also have the thing that's matching, right? So you have the regex and you have the match. And basically, it just gives you like step by step exactly what the engine's doing, right? So it says, okay, we're going to start the regex match. Bang. So what it's first going to do is try any number of these characters at whatever number of times, right? So I'm basically saying find either an A or a B 5 times in a row, right? So I'm going to step into that, and oh, good, it matched. Okay, cool. So now, next step, we're going to try and match the literal sequence B, 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 right? It's not going to work though, because that's an A, failed, right? So it's going to backtrack all the way to the back there to the second A and say, can we match five A's or B's? Yes, we did. Bang. Oh, da da da. So you can see regex are pretty stupid, right? They're just going to keep doing this, da 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 da, right? So, but yeah. So another cool feature of regex debugger is you can put it in heat map mode, right? Right now the red's just indicating that the thing has a match, right? But if you put it in heat map mode, it'll actually show you, how much of each how much time the regex engine has spent on each character there, right? So I'm going to put C, which is continue, and run this regex all the way through, and you'll get to see the match as it's running, and also, what time, which parts of the regex, or which part of the text the regex is spending the most time in. So you see it going on, da 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 da. Got a backtrack a lot there. Doesn't have to backtrack for the cues. Backtrack, 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 right? So it says after 204 different steps, the regex engine failed to match this, right? So you see the steps down there, 204, right? And you can also see it did a lot of backtracking and so on, right? So that's kind of regex debugger, and I'll show more in a second. But really cool program. It can do a lot, and it's pretty useful for performance metering.
This is useful if you want to try and optimize the efficiency of the regex.
Yep, absolutely, yeah. Or for example, it's matching something you don't understand why. It's got a really good explainer mode. It tells you what's going on. Yep.
Do you know how he's getting into the internals of how regex engine?
Yes, I'll get to that in a second. Yeah, there's. Yeah, absolutely. The next module I want to talk about, regex assemble. Really, really cool module. Basically, you can give it a whole bunch of regexes, and it'll glue them together and combine them into like a single regex, right? And there's a few reasons it might want to do that, right? The most obvious one is that for performance sometimes, right, you can compile this into like a trie data structure, and that way it doesn't have to iterate over each one of the things it's trying to match, right? So here I'll show you that in the Rx debugger here. Oops. So yeah, so here's the case, right? So in this case, I've got so it's 4 patterns and just like a random string of text there, right? And then yeah, obviously as you can see, this is like kind of suggesting they're going to be like nucleotides sequences, and you're doing matching for them, right? So in this case, the regex is it's going to look at each one of these, and let's see what it does. Okay, I'm going to capture to 1. Okay, so I'm going to try this literal sequence. Do I find that? No, I don't. Okay, well, or let's try the next alternative. Let's look at this literal sequence. Do I see that? No, I don't. Okay, fine. We'll go over here. Da 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 da. Really stupid, right? Look at it going. It's da 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 da. Right? Regexes are dumb. Right? So blah 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 blah. And if we well, let's put it in heat map mode. Right? Now we'll continue. Bang. So just running through those. As you can see, it's like spending a lot of time on each one and spending approximately the same amount of time on each one. Oh yeah, it speeds up after a while, by the way. So it failed to match. Okay, well that's not good. Look how many steps it took to, 571, right? Let's try doing it with the regex that regex assemble creates, right? Because regex assemble, analyzes these 4 regexes you feed it and builds it into one optimized kind of regex, right? So let's demonstrate that one. So, okay, cool. So we've got the same sequence, the match against, and the regex combined with regex assemble. Okay, cool. So let's see what happens. Okay, so we're starting a regex match. First off, does it start with TT? Because I notice that all of these sequences have the same TT starting, right? Does that start with TT? No, it doesn't. Okay, I can immediately move on to the next character. Da 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 da. Right? So let's put it in heat map mode. What happens? Now it's running through, and okay, yeah, so it has to backpack a little bit there when it sees the TTs, but look at it just burn through that, right? All the optimization it was able to do. And look at the number of steps it did, 185 versus 500 and something or whatever. Yeah, so it's pretty decent optimization. Also, regex assemble is often really useful sometimes when you've got like say an Nginx rewrite rule and it accepts just one regular expression. Well, you can, and let's say you want to have a whole bunch of things that matches, you can regex assemble them to one thing, bang, one rewrite rule in Nginx to do the thing. Yeah, so that's regex assemble, also really cool. Yeah.
There's a difference between having a very readable this or that or that to something very complex.
Yep, absolutely.
Yeah. Saying this is for this, and
that's
generated.
Yeah, and usually I find it's best if you don't paste the assembled regex into your code. Obviously, I think it's best if you like have your individual regexes, and it's just at compile time you merge them into one. You don't actually try and look at them too much at the assembled level. But yeah, it's regex assemble really cool. But how does it actually work, right? So if it just merged them together into this original one down here, it wouldn't actually know which one it's matching necessarily, right? But the way that regex assemble works is it uses the question mark curly brace directive, which actually runs code inside the regex engine when it's executing, right? So in this case, and this directive always matches true, right? It just runs the code and matches true. Yeah, so you got this regex.
So it tells you which one matched by the return value. Exactly,
and it restores the return value in $hat_r, right? AKA last regex code result. So yeah, so that way, when it gets down to the very level, stores it into that special variable, and the regex assemble can extract that special variable and look it up in this reverse lookup table to figure out which directive matched, right?
That is not a default code.
No, it's on CPAN, but it's been there forever, right?
No, that $hat_r is not.
Oh yeah, it is. It's built in. It's a special variable for the regex engine. Yeah, there's a few of them like that.
What is it normally? What's normally populated in that?
I think it's usually nothing. I think it's usually undef.
Right.
Yeah. I mean, it's only useful for this when you have question curly and when you have question curly. There. Yeah. But really, the point is that you can run code in the regex engine, right? Here, we're just returning like little integers just for lookup purposes. But really, you could return anything at all, right? All right, next module I want to talk about, regex grammars, also Damien Conway module. Really awesome module. It's like, if you remember back to like automata theory or whatever, it's like, regexes can't match hierarchical nested data structures, right? It's impossible, right? Well, with Damien Conway's,
Doug is making air quotes.
I'm making air quotes while I'm saying impossible. Yeah, so basically now it's possible, right, with regex grammars. Right. So, also, how you should never parse email addresses either, right? With regexes, well, with grammars, you can actually do it quite well, right? Instead of that monster 10-page regex that's in the RFC 822 Perl module, you can actually make something that's actually nice and is a recursive descent sort of parser, readable, yeah. So here it's like oh yeah, sorry, I skipped over this in the previous slide, right? All you have to do to use regex grammars is just, in a curly brace scope, just use regex grammars, and all of the regexes inside that scope will have grammar support if you want to use them. Yeah, so here basically you just go QR to create a new regex, and I've put the X little modifier down here so I can put comments and white space in, and then basically I just say match an address. Okay, well, what is an address? An address is either a mailbox or a group, right? And a mailbox is, either a name address or an address spec, right? Let's go to address spec, right? The address spec is you have the local part, and you have an @ sign, and you have the domain, right? So it's like just sort of this recursive descent sort of parsing, right? And you can make it really readable like this is, right? It's like this angle address, and that's where you have your name and then your email address in the angles. Basically, I can't remember CFWS is. It's something in the RFC. It's like collapsible something in white space. It's whatever. But point is, regex grammars are awesome. So yeah, I just want to show this really cool little program. It's called arith to Lisp, and basically, yeah, there's your Lisp always.
That's what I was thinking.
Okay, cool. So what it does is I've got the parser regex, And what it's going to do is going to match an expression, right? The start of the string, end of the string, expression, right? And then the expression, what is that? It's a term separated, two terms separated by a binary operator, or it's just a single term itself, right? And what is a term? Well, a term is either going to be a number, or it's going to be a parenthetical expression here, right? And then expression inside of it, right? Well, what is an expression? An expression is this thing, right? So you see how it's recursively defined, right? And then here's just your little, like, what is a number? A number is one or more digits. And what are all my binary operators that support? Blah, 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 blah. Now, here's the cool part, is you can also override the special token WS for white space. And what I've done is say that, yeah, white space is \s, which is normal white space, or it's one of these comments, right? You have your Perl style comment, which is a hash, hash character, up to the new line. And there's also the C style comment, which is /* bunch of stuff, */ right? And just like C style comments, you can't nest those, right? It's stupid design like C, but it's the way I coded it here. And just, one other cool little thing, in case you're wondering, the extra plus there is just to prevent extra backtracking, right? It's so that the regex engine will never bother doing a run of white space and then backing up one and then trying more white space or whatever. It just matches that block of white space all at once. And if it backtracks, it won't backtrack inside that match, right? It's just a little optimization for when you write grammars. Pretty useful. Yeah, it is. It's in the regex grammars docs. Yeah, like if you write a lot of regex grammars, you kind of have to use that. Otherwise, you have really crazy backtracking behavior that makes horrible match times. Oh no, well no, actually, it's part of the Perl regex. It's just especially useful when you're writing grammars. Mm-hmm. Yeah. And then it basically just does some stuff, and then it renders it in like a recursive way that's gonna spit out a list expression, right? So if I go Perl arithmetic list, and I put my expression here, I'm gonna go 1 + 2. Alright, then a whole bunch of stuff. I just have it numbered, but the important thing is this output here, right? This is the prefix notation for it, right? +1, 2. That's what you'd put into a list program, right? So.
Well, it's like RPM backwards.
Sort of, yeah. And then, let's just do okay, 2 times 3. Boom. And then here's your prefix again. +1 times 2, 3, right? And, you have to believe me, but you can arbitrarily, these guys can go 2 - 9, bang, and it just gets more and more complicated, right? And just, as a little demo, let's put a little comment in here. Hello world. Bang, treat it as white space, ignored it, right? That's regex grammars, right? Recursive descent parsing, right in the regex engine. And it's more efficient than Park's rest descent if you know that, because the regex engine is more optimized than Damien's Perl code. But yeah, regex grammar is really, really cool stuff.
Hang on, before you go further, can we back up to the second module?
Sure.
The compiler one. You said you can compile it at runtime rather than having to put that thing in there. How complicated?
It's not too complicated. Just look at the Perl doc. I think basically all you do is you create an RE object, and then you call the add method on it a bunch of times, like no matter how many regex you want to add. Basically, all you have to do is you create this RA, and that's just a new regex assemble object, and you just add all the different regex you want to add there, right? So if you wanted to do it at right before compile time, you could do it in a begin block, or also you can create a regex with the one-time compile thing. So if you go Perl-e my re equals qr blah blah, and you have your regex in here. If this is in a loop or something, it might actually compile this regex multiple times, especially if you have something like this, my regex, right? However, one special thing you can do is you can put an O at the end of that, and that means to compile this just once, right? Yeah, so that's a handy trick, especially if you're building up these things at runtime there. Yeah. So reg assemble, regex parameters. Now I want to talk about regex exhaustive. Really cool, somewhat obscure module, but you don't need it very often. But sometimes when you need it, it comes in super handy, right? Basically, the the core of the issue is that when you're trying to find all of the matches in a string, right? How many different ways are there to do that, right? If you look at the standard Perl way, which is like the G modifier to a regex, where you say find me all the matches, the way that actually works is it finds a match and then it stores in the special pause variable the end of the match, right? And at that point, when you're trying to fetch the next match, it jumps back to this pause variable and runs the regex again to find the next one, right? Well, that's all fine, well and good, but it won't find overlapping matches, right? So for example, in this case, if we have AA, how many different AAs are there in that string, right? The standard like find all or the m/g at Perl will give you the 2, right? Regex exhaustive is if you want to find every possible match, right? And I'll show you some examples in a second here, but oh yeah, right. So, and let's see how it works, right? Well, the same way. It works by injecting code into the regex engine, right? So in this case, what you do is, what the module itself does, what regex exhaustive does, is it appends the same directive at the end of your regex, the question mark open curly, and then put some code in there, right? And what that code is going to do is it's just going to record where it is in the current match, right, as one of the output fields, right? And then it's going to use this other special regex directive, star fail, and what that does is it just always fails the match, right? So what regex exhaustive does is after it transforms this engine, once it transforms your regex into this specially modified regex, it just runs it against your pattern, right? And then every time, what it does is it matches against all the text you're trying to match against, and then it's going to, if it succeeds, get to record match and record the current substring that you've already processed, and then it's going to artificially fail it, right?
Oh, nice.
And yeah, and then once it fails it, it invokes the backtracking behavior, and it goes all the way back, advances, tries to create it again, right? So it's going to find every possible combination. Okay? So here's a simple example of how you could find every substring inside of a string, right? So you see you've got like, the string is just any sequence of one or more characters, right? So you have, ABC, which is the entire one. You have AB, A, BC, B, C, right? Gives you every possible substring. Yeah, regex exhaustive is pretty cool. So here's okay. So here's a little bit of like Perl kind of insane hackery. There's this trick invented by Abigail, I think, to factor integers using nothing but the regex engine, right? So I'll just walk through this in a sec because I think it's pretty neat. But what you do is you pass in a number of that you want to determine if it's prime or not, and then you create a string of that number of one-digit characters, right? So like, let's say you pass in 7, right? You pass in the number 7. It creates a string of 7 ones, okay? And then what it does is it tries to match that against this regex, right? And what this regex is going to do is it's going to it started at the anchor here at the start of the string, and then it's going to try to match 2 or more characters, right? And then assuming it matches 2 or more characters, which it would in the case of 7, then it's going to advance onto this \1, right? And that's a back reference, right? So it's going to say those 2 characters I matched before, try to match those 1 or more times, right? And then it's going to match all those characters all the way up to the end, those 2 characters. In the case of 7, it would go, the original 2, and then another 2, that'd be 4, another 2, that'd be 6, and then it can't match that last one dangling character, right? So it would fail, right? And then it would backtrack all the way up and then try 3, and that wouldn't work, 4, and so on, right? However, if the number has a divisor, like let's say the number is 4, then you would first match those original 2, and then you would match 1 back reference, and then you'd be at the end of the string, right? So that would mean that 4 is divisible by 2, right? So just an insane, like crazy Perl bit of lore.
Good interview question.
Yeah, maybe. Yeah. Yeah, right.
Depends on what kind of ticket you're on, I guess.
Factor an integer with nothing but the regex
We
expression.
have to ask that.
So with regex exhaustive, you can do the exact same thing, and you can find all the divisors of the number using regex exhaustive. So it's pretty neat like that. And basically just works the same way. Is that it's just that for every successful match, it also records what that match was, and then backtracks and tries it again. So it'll find every divisor, right, using nothing but the regex engine. But yeah, I probably wouldn't implement your number factoring this way necessarily. By the way, there's a cool Unix program to do that for you, right? But yeah. Okay, so regex is awesome, but don't use it for factoring integers. Yeah, so I want to talk about this one module I wrote. Yep.
So where could you see a realistic use for regex?
Let me tell you in 1 second there, buddy. Yeah, I mean, one of them is, for example, with bioregex that I'm going to talk about in probably the next slide. But yeah, like you're right. You don't use it that often, but sometimes when you use it, it's really useful. Yeah. So yeah, bioregex is this module I wrote just to look for different patterns and to manipulate DNA sequences in a variety of ways. Right now, it supports DNA and RNA. I've kind of planning on making it work with protein sequences too, but I haven't really got around with it. Yeah, the thing is that, unlike like a standard string, which is just essentially like a linear array of characters, DNA is a little more complicated, right? Like it has more different possibilities, right? One of them is that it can exist in a circle shape, right? Whereas normally if you look for a pattern and it's overlapping the start and the end in a string, you won't find it, right? But if you're looking for patterns in circular DNA, you need to be able to find those, right? Also, DNA is often double-stranded, so you might be looking for a sequence that could be matching either on the forward strand or on the reverse strand, right? Since they're complementary. So that's kind of what bioregex does, and it does it with the regex exhaustive. So it finds you every possible match, and I'll talk about an application of that in a second. Another feature of bioregex is the IUPAC codes. They're kind of like character classes, actually, right? Like, so as you guys probably know, there's like 4 bases in DNA and RNA, but it's just that it's uracil instead of thymine. But yeah, there's four bases in DNA, right? However, let's say you want to match like 2 of those bases. You want to match A and G, right? Well, there's a special letter in IUPAC codes designated for that, right? Like for example, Y here is a shortcut for matching either C or T, right? So in a way, you can think about it kind of like a regex character class, right? Because regex character classes are like you have \W and that matches any of the word characters, right, or the C identifier characters, right? It's just the same sort of thing in chemistry or biochemistry. Yeah, and yeah, also when you order like primers, which are like things to latch onto particular pieces of DNA so they can be copied and amplified. Sometimes you don't know exactly the sequence that you want to latch onto, right? So when you when you order these primers, you can actually specify, instead of making this primer be an A, you can or like a C, you can make it a Y, right? And that way it would match either C or T, right? And the way they would work this is when they ship you the primers, half of the molecules in the primer will have a C in that position, and the other half will have a T in that position, right? And you can do like whole bunches of these different various combinations, right? And although it does like exponentially shrink at every one you add, remember you're getting like billions of these molecules in a shipment, right? So you still have tons and tons of them. Another advantage of bioregex is because it uses sort of like regex assemble kind of techniques, you can create the regex that scans on the first, the primary strand, or like the coding strand, and then also the one that scans on the other strand, the complementary strand, merge those together into one regex, and then just do one scan through data, right? And the advantage of that is that you don't have to, it's like, say you have like a huge 100 megabyte chromosome, whatever, right? You don't have to read that in memory, reverse it, and then run it again, right? And also, if it's too big to fit in memory or cache or whatever, you don't have to scan through it twice, right? You can just scan through it once, improving memory locality, right?
And is the performance better? Presumably, yes.
Yeah, definitely, yeah. Then running a regex twice.
Yeah, I'm just thinking if you take a simpler, the one direction regex, you run one way or you run the other way, and you compare that with this much smarter one than just running one way. How does that compare?
Good question. Yeah, I mean, I have to benchmark it versus what what the other regex is.
Mm-hmm.
Yeah, I think like if you really wanted to optimize it, there's even other ways to do it too. Like you could use a Rego program, like I talked about a while ago, which actually compiles your regexes down to C and also creates them into like a DFA, and that would really just scream, right? But yeah, I think it's for most applications, I think this is probably suitable, right? Another really cool another really cool part of this, and kind of related to Alex's question there about how exhaustive is useful, is often you want to use these things called restriction enzymes, which will cut DNA at particular sequences, right? What you often want to do is find every possible molecule that could result after these cleaving, right? And some restriction enzymes can cleave in multiple ways in overlapping places, right? So if you just look for every subsequence of these things, you might miss some molecules that could potentially end up after a restriction enzyme cleaving, right? So that's one application of the reg exhaustive, right? One other advantage of the regs assemble is you can assemble a whole bunch of more than just two, right? The one strand and the other strand. You can assemble like a dozen restriction enzymes, all combine them together, and then run that in one scan, right? And it gets to be quite efficient because it takes advantage of that try sort of optimization that regs assemble does. Yeah, another design criteria is that it should search in circular inputs, as I said before, right? Yeah, so in this case, it avoids copying the entire data structure and like shifting it or whatever, and just copies the little ends, reverses them, and scans it, and then merges the results together. Yeah. So yeah, now I'm just gonna switch gears a bit, talk a little bit about some Unicode stuff. Yeah, Perl's Unicode is actually really cool. There's a lot of stuff you can do with it, especially if you get like the latest Perls that support all of the like Unicode 6.1 or whatever. Yeah, like really what I just want to talk about on this slide is Unicode properties, and in this case, yeah, it's the \p, right? And what this is doing is matching \p Greek, and it's matching the Greek script, right? You can also match blocks, but blocks and scripts are a little bit different, right? Like for example, there's blocks are really just like an artifact of the Unicode, how Unicode is specified, right? So you have like the ASCII block, right? That has part of Latin script in it. It also has other languages use that script too, right? So usually you want to use script, but sometimes you want to use blocks. Yeah. So here's just a little simple example about how round tripping doesn't really work in the Greek language, right? Because there's actually two forms of lowercase sigma, like you can see. Here, this name is Theseus, by the way, and it's you got this lowercase sigma in the middle, and you also have this other one at the end, which is kind of a weird-looking one. That's also lowercase sigma.
The sigma differs whether it's in the middle or the end of the word.
Exactly, in Greek language, yeah, yeah, and it's yeah. I mean, other languages have even more, depending on where they are in the word, even more variations. But in Greek, I think that's just the one. So yeah, in this case, the problem is that if you like uppercase it and then lowercase it, you lose that distinction, right? So here's just a tiny little regex using a negative look behind assertion, and then just says, yeah, anything, any sigma that's followed by a character in the Greek script, yeah, we should change to the lowercase terminator sigma there, and you can see that if you Greekify it, it brings Theseus' name back in the normal way to show it, right? And then Greekify, and then yeah, if you have like 5 sigma, then it won't, change that one.
Because LC presumably only works on a character-by-character basis, but it doesn't look at the overall word.
More or less, although that's actually not entirely true, because there's some languages like German where 2 characters will, when case changes them, it will actually change into 1 character. And yeah, it's just some odd examples like that.
Double S.
Exactly, yeah, that's what it is, yeah. And then yeah, here's another awesome module that I like a lot, text unit decode. It's not a translator module, it's a transliterator module, right? So it tries to basically just make it so that like whatever you would say, it turns it into like the kind of like US sort of standard pronunciation of it, right?
Oh, fascinating.
Dozodania, yeah. So yeah, you can judge for yourself if you think those are any good or not. But yeah, I chose those 3 languages because they're in a lot of linguistic classifications quite different, right? And mostly is due to how they handle vowels. Cyrillic and Latin and so on typically spell out every vowel in a word, right? So it's fairly easy for text unit decode to work with it, right? So that's why you have Dosodani, which looks awesome, right? Thai, it indicates vowels, but it does it with like accents and also special modifier swipes and so on, and it's really complicated just to, if you look at how like they spell the consonants and they kind of indicate vowels in other ways, right? And the Arabic, as I understand it, doesn't really write vowels at all. yeah, so you can judge for yourself if text Unicode actually works. Well, I don't know, but
So there's like UN standards on transliteration, right?
yep, there are.
So do they implement the UN?
Mostly. Actually, the guy has an awesome article. I really recommend it. If you go to so yeah, essentially the guy ordered the entire stack of Unicode standard, which is like this big, and it has the transliteration stuff in it, and he mostly went through and hacked it as much as possible without making the implementation ridiculous, right? Because some languages, especially some of the Indic languages, are just it would take a native speaker decades to make this kind of stuff. Yeah, this one that does read it. It's a really good article. It's awesome. He talks about how he's like a linguistic guy, and he basically just started with this one language. He's like Jawahi, and he's like, can't be that hard. Go through this. He starts looking at all the other languages, and the article is basically about how just hack it in a smart way, and minimize the amount of work you had to do. Yeah. All you have to do is just go to the C page for text Unicode. Oh, is that too much work? Okay, fine. Oh yeah. The other thing is there's actually a Perl IO modifier you can do in that, which I put in there because at YAPC there was a talk on the Perl IO stuff, and sort of people are thinking of cool applications you can do with that. But yeah, you can say that after you do UTF-8 decoding, you need to decode it for as well. Perl lets you chain all these encoding things together when you open a file, right? It's really flexible. So yeah, here's just a simple little regex that I just whipped up to sort of take advantage of text unit decode in some ways. So all it really does is just take an argument that's some kind of text or whatever, and it's going to annotate it by making the phrases in another script and putting brackets after them and putting the text unit decoded versions after them, right? So as you can see in the bottom here, it's if you had a form and someone from China just entered some stuff, if I looked at that, I'd be like, I have no idea what that is at all, right? Whereas at least now I can see city, Shenzhen. Oh, okay, yeah, I know where that is, right? That's southern China. And I don't really understand Chinese names, but at least you have something to go on, right? Text Unicode is the last resort of something, right? It's when you want to transliterate something, right? Yeah, let's look at the way that this actually works, right? So what I've done is create a substitution regex, and what I say is match any character that's not ASCII, right? Remember, that's what capital P does, right? Lowercase p will match something that is ASCII. Uppercase p will match not ASCII, right? Just like all the other regex character classes, right? \w is any word character, whereas \W is anything that's not a word character, right? Yeah, so I'm saying match anything that's not an ASCII character, and then match everything until I hit something that's not Latin, right? So what that's going to do is it's going to scan through here, ASCII, 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 ASCII. Oh, this character, well, technically extended graphing cluster is not ASCII. It's something else, right? So at that point, it's going to continue matching, match until it finds something Latin, right? Spaces are not Latin, right? Even though they're in the ASCII code block, they're not a member of the Latin script, right? So blah, 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 bang, it hits city, right? And that's important, although I didn't illustrate here, because if you have multiple words in another script, you're going to want to pass that all at once to text unit of code. So it improves it, right? Keep doing that. Okay, cool. So yeah, blah, blah, it does it, and then after that, it just extracts the match and then returns what you want to turn into it, right? In this case, I preserve the match itself, but then I add the brackets around it with the unit decoded output, right? So that's how you get the Shenzhen followed by the Chinese characters, right? Yeah, and here's another kind of thing is bidirectional writing. I'm not talk too much about the support for that in Perl, but it's pretty good. However, yeah, one thing I do want to talk about is boustrophedon writing, which is something used in ancient Greek. We always think about writing going one direction or the other, but it turns out is which I find really neat is that way back in the day they used to write going one direction and then flip around, mirror image the text, and then go back the other direction, right? So you can see here, you've got on this line, you've got E's going in this direction, and it goes all the way around, and like here's an E in the opposite direction, right? You see how it's mirror image like that? Yeah, yeah, seriously, good for dyslexics. Yeah, and then you can see how it's like, yeah, there's C's going in the forward direction, or the normal direction we would think about it here, and then there's C characters going the other direction, right? Yeah, the reason why they call it booster feed in because it's like as the ox plows, right? It goes back and forth as if an ox was plowing a field. So basically, here's the least useful Perl module ever. I haven't uploaded this yet. I haven't decided if it's too stupid or not, but yeah, basically, you can see how it works. You feed it some text, and it makes it into as the ox turns. So Achilles glared at him and answered, "Fool, prate not to me about covenants." Yeah, you guys all see that? It's mirror image. There can be no covenants between lions and man. Wolves and lambs can never be of one mind, but hate each other through and through. Therefore, there can be no understanding between you and me, nor may there be any covenants between us, till one or other shall fall and glut grim Ares with his life's blood. Right?
Does that just LTR and RTL in the code character?
No, unfortunately it doesn't, because there's not mirror image fonts support for Latin. Or most languages, most scripts. But yeah, the way it does it is a complete hack. It takes Unicode characters that kind of sort of look like the mirror images of the Latin characters. So like instead of C, there's like some special, like in probably Cyrillic script or something, like a lowercase c that's backwards or whatever. So it completely hacks it like that.
So it's just big mapping.
Basically, yeah. Yeah, it's I mean, I can show you it. Not really, bud. Not really. Yeah, I did. Here's the map table, right? It just like lists every, every possible one, and then pretty much just splits the sucker and puts them into a big hash table for lookup.
And what's the basis for the upside down here?
Yeah. Okay. So there's actually different types of writing that's classified as booster feeding. There's also one in like Easter Island or like somewhere in the like Pacifics or whatever, where they do a different type of booster feeding, where it's actually
It's upside down.
it starts at the bottom. Here, I'll try. I'll show it to you. Let's say. I think. Okay, good. I still have the original thing here. Okay, so I think if I go. Spell that right.
Go from DNA to ancient Greek. You can't spell it.
Okay, cool. Okay, cool. And then I think it's just like, oh yeah, it's just okay. Oh, true.
Now.
Okay, cool. So yeah, the way it works is it starts at the bottom here. Achilles glared at him and answered blah, blah. And then what happens is that you take the tablet and you flip it around like this, right? And then you read the next line, right? So you're reading da 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 da, and then you flip it around. It's actually supposed to be rotated. It's just a hack that it's upside down right now. It should be more rotated, but you can kind of see it, right? Like, yeah, the way I tried to do it was like the way I did the other one is, I read it like this, and then I flipped my laptop upside down like this and read it. Basically, every time you read a line, you flip the tablet and you read it.
I can see how that didn't catch on.
Yeah, that one, yeah. The Greek one I can see. You kind of like move your eyes less, right? This one is a little bit less practical.
These are stone tablets though.
Yeah, this one's really cool. If you take a mirror and you hold it up to this, you can read these lines really awesome, right? But the other ones, of course, look, mirror image and screwed up. Doesn't? Yeah. Okay. Fine, guys. I'll move on to serious stuff. Okay, fine. None of your business. Okay, cool. So, next thing I want to talk about is some really cool advances that have been happening in the regex engine, right? Remember how a lot of the modules we looked at relied on running code inside the regex? That's always been supported in Perl. However, the problem is, what if that code itself ran a regex, right? Would that break anything? It turns out that prior to Perl 5.14, yes, right? And the reason for that is that the regex engine isn't reentrant, right? Reentrancy is a little bit different than thread safe. Yeah, for example, like most malloc implementations are thread safe, but they're not reentrant, right? And the way they accomplish that is that every time malloc is called, each thread that calls it will try and acquire a mutex when it's accessing some kind of state in the heap, right? However, the problem comes when you have a signal delivered to a thread, right? And let's say that signal is in the middle of processing malloc, right? When that thread gets a signal, if that signal handler calls malloc itself, it will try to acquire the mutex, which will immediately succeed because the thread already has the mutex, and it will go into malloc, right? Even if it didn't, it would deadlock, right? If it didn't allow it to succeed, right? So it just doesn't work, right? So basically, moral of the story is never call malloc from a signal handler, right? In fact, you should never do anything in a signal handler that isn't async signal safe, according to POSIX, right? Just because it'll, potentially user space data structure will be in an inconsistent state when they're accessed again, when they're re-entered, right? So awesome work in Perl 5.14. Now you can actually call regexes from inside the regex engine itself, right? So let me just show you this. Oops. Okay, cool. So I'm going to look at my Perl. Okay, so I have Perl 5.14 here, right? Let's go back to Perl 5.8.9. Okay, I'm 5.8.9, right? Now if I run this, segmentation failed. Uh-oh. We can Perl. Okay. Oops. Okay, wow, okay, that's a big, very backtracing. But yeah, basically it's, not safe to do that. Don't ever do that in Perl 5.8, right? Yeah, and I don't know if you saw how that actually worked, right? It's it basically it tries to do a match against this X string, and then inside that match, it tries to run another match against another X string, just an empty one, right? Basically, the moral story is don't do it as bad, right? However, if we upgrade ourselves to Perl 5, actually, I think whatever my usual one is, let's get it. Okay, 5.14, right? So now, if I run this, oops. I'm second guessing myself now. Let me test this. Okay, yeah. Way to make a liar of me. Fuck. What is going on? All right. I must be doing something wrong.
I think we hear the black helicopter.
Yeah. Okay, I'm gonna look into that later, but I'm sure I'm doing something stupid. But the Perl engine, regex engine is reentrant now, I think. Okay, cool. So, and yeah, the consequence of that is that you can write much more complicated regexes with that run code themselves that use regexes, right? Which is really powerful. What the heck is going on? I don't understand that. Is that right? Weird. Weird. Okay, I'm gonna look into that and possibly talk to someone about that. Yeah, so what it's trying to do is it's trying to match this X string against this regex here, right? And what this regex here is doing is using the question mark open curly, which what it does is that when we get this part in the match, it actually runs this Perl code. Right? Yes, sort of, yeah, basically, yeah. It doesn't, it'll pre-compile it so that it doesn't actually have to eval the text source, but yeah, it runs like a Perl sub. And what does this Perl sub do? It runs another match, right, with its mregex. Yeah. And I really don't know why it's failing, but yeah. Weird. I don't know. Okay, sorry about that, guys. Okay. Yeah, it's, I don't know, I'd have to analyze how it actually constitutes the data structure, see if it could, be exploitable in any way. Yeah. That's odd. Okay, anyway, continuing on. Yeah, so the other thing I want to talk about is this bug that was actually finally fixed. And this one, I'm just going to leave if I can't show you guys it's fixed, but yeah. It's the reason behind this bug was that in Perl, they always tried to make strings terminated with a null byte, like in C, right? And I guess probably the reason for that is that a lot of like system calls and so on require a C-style string, right? So if you know it's terminated by a null byte, there's no null bytes in it, you don't have to copy the string at all. You just invoke it as a system call, right? However, Perl lets you store null bytes in strings themselves, right? So it has to store the length separately. It can't rely on the C-style thing where it traverses the string and looks for the 0, right? So which is normally fine, whatever. But Perl regex has long since tried to copy that null byte out when it reads the regex, right? Which is normally okay too, even if there isn't a null byte there. It'll just read some extra piece of garbage that gets ignored because the length is stored separately, right? However, often people use Perl strings to point to things that aren't memory managed by Perl, right? Like memory map files are a really good example, right? So a file mapped is exactly the size of an OS page, which is typically 4K, and the OS chooses just some random address for the mapping where there's nothing else around it, like no mapped memory. Then if you try to read that null byte 1 byte after, it goes into a page that isn't mapped, right? And at that point, you have a segmentation fault because you tried to access memory that isn't mapped to any a virtual address, or like a virtual address that isn't mapped to any actual memory, right? So on OpenBSD, you actually don't have to do anything at all to anything special to reproduce that. You just map a 4K file and then run a particular regex against it. But on Linux, the way it works is that it allocates a page, it allocates your mmap, and then immediately below it, when you do another mmap allocation, it'll do it immediately below it too, right? So it's actually pretty hard. It's actually not trivially reproducible on Linux, but one thing you can do is protect it, is make these gap pages yourself, right? And yeah, gap pages are essentially 4K that are mapped. 4K that are mapped. You create a 4K mapping, and then you protect none that so that if you try and access it, it will throw a segmentation fault, right? Because you've removed read permission, you've removed write permission, you've removed execute permission. You can't do anything with this page at all, right? So let me show you this little program right here. Crash.pl. It does exactly what I said inside, right? It just creates a gap page and sets it to prot none, and then it creates another mapping. Oh yeah, dev zeros, there's a device you can map to get a bunch of zeros if you want, right? And yeah, so it tries to do that again, and then it runs this particular regex against it, which just matches the last character and reaches the end of the string, and Perl will segfault. I really hope. Okay, good. So that is not working good. Now let's upgrade. Okay, thank you. Whew. Okay, good. Yeah, so it's deep in the bowels of the Perl regex engine. Yeah, so that's just a very, very obscure bug. But if you're doing things like mapping files that are, of arbitrary size, you might be susceptible to a DOS, right? Like, because if an attacker uploads an exactly 4,096 byte file, and you're using this particular memory mapping thing, then you might have a seg fault in your map. So just FYI, just they're always proving stuff in Perl, in the Perl regex, and that's pretty much all I've got there. So those are the modules I talked about. And yeah, if you have any questions, we'll try and answer them.
So that last one you showed us is a bug in the special engine?
Yeah. 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 I mean, it's yeah. I guess it took a little bit of interpretation to have it construed as a bug, because most people hadn't considered of using memory map files as strings before, right?
But I mean, a dollar typically, the symbol explanation for that is it's the end of the line. But a more complete explanation would be wherever the data ends. So if it knows that the data is 4K1, it does a match with 4K, but at the very end, it should say, oh, I don't need to go to the next line to see the zero. No, because I know that's the end of the data.
Yeah, you think so? Yeah, and 520 does that. Yeah, so that is how they fixed it. Yeah, it never reads an null byte anymore because it doesn't need to. Yeah, well, I don't know. I can go look at the patch, but it shouldn't ever need to read the null byte, right? Because it always has the length stored separately, right?
Yeah, interesting.
Doesn't?
Just getting back to the regex debugger question that I had earlier about where is Perl getting all that information regarding your regex sequence.
Yeah.
To compile that module is he doing like some excess stuff to get out that?
No, I think so. The way that regex debugger and regex grammars work is it actually has a parser for your regex, and I'm pretty sure that regex grammars does for sure. I'm pretty sure regex debugger works like it too. It parses your regex and then actually adds little extra code executor things inside of the regex at certain places, like right after every single bit of matching, right? Yeah. So if you have like some literal text, it'll put one of those open parens question mark open curly, and then when you get to that point in the regex, it'll actually call out and say do some stuff, right?
Yeah. So it's not doing anything.
For grammars, no. For debugger, I don't think so. No.
It does turn on regex debugging. That's a lot of.
Oh, okay. Yeah, makes sense. Because there is actually, like Matt's saying, another regex debugger is built into Perl, I think. Is that right?
I think so. It says some further information that obviously was here with the internals. No sense at all.
Cool. Thanks for listening to me, everyone.
That was scary and awesome.